Have you ever wondered, among the billions of stars, whether there are strange objects silently passing by, carrying mysteries that humanity has never seen? And if you look up at the night sky, can you spot an interstellar messenger? A visitor like Oumuamua that challenges every theory we know? In the quiet darkness of 2017, in the distant sky, a small but unmissable object appeared. Oumuamua, its name comes from Hawaii, meaning messenger from afar, drifted silently, carrying mysteries never seen before. The object was slender, long like a cigar. Its surface reflected a strange light, like dull metal in the sunlight. Astronomers observed every tiny oscillation, every bit of reflected light, to try to explain why it accelerated away from the sun without leaving a tail or escaping gas. The strangest thing was its speed. Early measurements recorded a velocity of about 26 km/s, but as it approached the sun, its speed increased to 30 km/s, a phenomenon that natural comets have never exhibited. These observations caused many scientists to pause, to wonder, was this just a rare natural phenomenon? Or a trace of extraterrestrial intelligence? Harvard professor Avi Loeb, who first made the hypothesis public, posed a profound question. It is possible that Oumuamua is a sophisticated technology designed to maintain a stable orbit and remotely observe its surroundings without being destroyed. Every little detail, every measurement, every reflection of light, all became valuable clues, helping the astronomical community realize that the natural world could no longer explain all phenomena. Telescopes around the world quickly focused on Oumuamua. Every orbital measurement, every light fluctuation, every tiny change in velocity was carefully recorded, meticulously analyzed. Its speed increased from 26 km/s to 30 km/s as it approached the sun. Its estimated mass was about 10 to the power of 9 kg, and its slender shape challenged all predictions about gravity and outgassing. Amateur astronomers also joined in recording the data, with each image, each orbit tracked, each step helping to build a complete picture of the object's behavior. To not miss the next discoveries, click subscribe and like the video. To follow each measurement, each observation, and feel each light fluctuation that Oumuamua brings, as if you were touching the mysterious rhythm of the universe. Spectral analysis shows that the light reflected from the surface is not uniform, with alternating dark and bright areas, similar to a matte metal, giving the object a feeling of not being entirely natural, suggesting the possibility of the existence of sophisticated structures never seen before in nature. The data from Oumuamua are not just physical data, but also a lesson in perception. Humanity learns to observe analyze, and prepare for the more complex interstellar objects that will appear later. When Oumuamua was discovered, both the scientific community and amateur astronomers were stunned. Traditional physical models could not explain the object's unusual acceleration and its eccentric orbit. The smallest data points, light fluctuations, orbits, velocities, all raised unanswered questions. Major research institutes, from Harvard to ESO, began to compare data, create models, but still could not fully explain. This highlighted the limits of current theory and encouraged scientists to think more creatively, searching for mechanisms that had never been known. The philosophical implications also gradually emerged. Oumuamua was not just an object, but a reminder of the limits of human perception. It taught that, in the universe, not everything can be explained immediately, and that sometimes observation, patience, and learning are more important than explanation. Astronomers began to be more cautious, to observe more closely, to note every little signal, every fluctuation of light, and to learn to compare, verify, and imagine possibilities that current physical theory could not explain. Oumuamua became the first lesson of what would come next. More complex interstellar objects with extraordinary behavior and the ability to interact delicately with their surroundings, bringing new challenges to science and human understanding. Observing Oumuamua goes beyond orbit and speed. Astronomers use light spectroscopy to analyze the surface composition of the object, a sophisticated method for identifying its material and structure. The light reflected from Oumuamua shows slight variations from section to section, with bright areas alternating with dark areas, as if the surface is not uniform, with characteristics different from any other comet or asteroid observed. Measurements show that the reflection of light ranges from magnitude 2021, with brightness varying depending on the viewing direction, corresponding to its rapid rotation and unusually tilted orbit. These data suggest that Oumuamua may not be entirely natural. Its slender yet stable structure, its sophisticated orbit, and its unique light reflections raise the question: does this object have a sophisticated or reinforced internal structure to survive its passage through the solar system? Every spectroscopic measurement, every oscillation of light was meticulously recorded and analyzed, giving the scientific community a rough idea of its structure and materials. The deeper meaning is, Oumuamua is not just a physical phenomenon, but also a lesson in observation and interpretation, helping humanity prepare for the more complex interstellar objects that will appear in the future. When Oumuamua appeared, the global astronomical community immediately focused on observations. Researchers from Harvard, ESO, and many other observatories analyzed the orbit, speed, light, and plasma oscillations. The results did not match any previous physical models, making the scientific community surprised and cautious. Every hypothesis had to be tested. Every small data became an important clue. The philosophical meaning gradually emerged. Oumuamua was not just an object, but a reminder of the limits of human perception and observation. It taught that, in the universe, not every phenomenon can be explained immediately. And sometimes, patience, careful observation, and learning are more important than explanations. The scientific community began to change the way it thought and approached data, learning to see interstellar objects as lessons in complexity and surprise, preparing for the more sophisticated discoveries that would come in the future. From Oumuamua, humanity realized that each interstellar object was not just a physical phenomenon, but also a lesson in knowledge, awareness, and humility before the vast universe. Oumuamua was more than a one-off discovery. It changed the way humanity viewed the interstellar universe. The measurements, spectral and orbital data seemed to be clues that opened up new directions of research. Every small detail was analyzed and recorded to prepare for more complex phenomena later. These discoveries spurred the development of observational technology, from ground-based telescopes, satellites, to sophisticated computational models. Humanity learned to integrate limited data, compare between different interstellar objects, and understand that each signal, each light fluctuation, was part of the larger story of the universe. The long-term significance also lies in the change in scientific philosophy. Discovery is not just about explaining phenomena, but also about focusing on observing, learning, and cultivating the ability to reason about phenomena that are beyond all theories. Oumuamua became the first lesson, reminding humanity that the universe is vast, always filled with wonders, and that each new discovery opens the door to a deeper understanding of the interstellar medium. Oumuamua was not a one-off, but a precursor to further interstellar discoveries. 2 years later, Borisov appeared, bringing with it unique characteristics: a gas tail, a speed exceeding the standard, an unconventional orbit. Humanity began to recognize a hidden pattern. Each interstellar object had a different level of complexity, as if challenging human observation and analysis. The successive appearance of interstellar objects not only created a series of scientific data, but also an opportunity to learn. Humanity had to compare orbits, speeds, luminosity, and chemical characteristics to recognize common and different denominators, and to imagine how each object might interact with the solar system. From Oumuamua to Borisov, An evolutionary chain of observation and understanding gradually took shape. Humanity learns to adapt, increases its analytical, reasoning, and creative abilities, preparing for the emergence of more complex objects. 3I Atlas. This chain of connections suggests that interstellar objects are not just random phenomena, but may be continuous lessons, teaching humans about the laws, surprises, and intricacies of the universe. Measurements of Oumuamua's orbit have caused great confusion in the astronomical community. Not only did the object initially move at a velocity of about 26 km/s, but as it approached the Sun, it accelerated to about 30 km/s. A phenomenon that natural astronomical models could not explain. Oumuamua's estimated mass of about 10 to the power of 9 kg. Its slender, long, and narrow shape, combined with its unusually fast acceleration, suggested that the object did not interact in the way that conventional comets do. Astronomers used data from multiple stations, including JWST, ground-based telescopes, and Mars orbiter radar, to record its tilted orbit, its light wavelets, and its speed changes. All measurements were consistent, reinforcing the idea that Oumuamua did not obey the laws of physics. This extraordinary behavior is not only a scientific challenge, but also opens up opportunities for philosophical reflection. Humanity must learn to observe carefully, be patient with phenomena that are beyond prediction, and accept that not every object has an immediate explanation. Through these measurements, the scientific community realizes that Oumuamua is not just a physical phenomenon, but a lesson in the limits of perception and analytical ability. Before the interstellar mysteries that will appear in the future, Oumuamua was more than just a strange object. It was a wake-up call for the entire astronomical community. Observations of its unusual orbit and unexpected acceleration forced scientists to reconsider familiar assumptions. The object opened a new window into interstellar research, not just in terms of physics or orbits, but also in terms of the ability to identify and analyze unconventional behavior. New methods, from sophisticated orbital modeling to reflected light analysis, were tested and developed thanks to the appearance of Oumuamua. The deeper significance lies in the way it changed the way humanity thinks about the universe. The unusual data made scientists realize the universe may contain phenomena beyond current theory, and understanding them requires careful observation, patience, and creative thinking. Looking ahead, Oumuamua becomes a new benchmark, a stepping stone to more complex interstellar objects and discoveries that will challenge humanity's ability to analyze, model, and perceive in ways never before imagined. As Oumuamua left the observable horizon, humanity no longer felt that the universe was simply a series of known rules. Instead, a window opened, inviting astronomers to continue observing and pondering. 2 years later, Borisov appeared, bringing with it the characteristic gas tail, super speed, and unusual orbit, a step forward in the series of interstellar phenomena that Oumuamua had initiated. And just a few years after that, 3I Atlas appeared, with its hollow structure, unique reflections, and strange radio signals. This series of 3 interstellar objects seemed to increase in complexity, challenging humanity's ability to observe, analyze, and perceive, opening a new journey in interstellar research. The first observations of Oumuamua became a foundational lesson, preparing us for more complex objects and raising the big question: will the next objects be natural phenomena or traces of a sophisticated and purposeful extraterrestrial intelligence? With each slow rhythm, each measurement, and each reflection, humanity learns to listen to the cosmos and embarks on a mysterious interstellar journey, of which Oumuamua is a mysterious yet promising starting point. In mid-2025, a strange object appeared in the sky near Mars. First discovered by JWST stations and ground-based telescopes, the object was named 3I Atlas, a distant visitor, carrying phenomena that humanity had never observed. From the first appearance, astronomers realized that 3I Atlas was different from all previous interstellar objects. Its orbit and velocity did not follow any familiar physical laws, creating a series of unanswered questions. The light from the object reflected steadily, with a magnitude ranging from 18.7 to 19.3. The surface was slender but still maintained a stable structure, giving the feeling of a living object, observing the surrounding universe. Scientists immediately focused on tracking every detail: orbit, speed, reflected light, plasma oscillations. Every data was carefully recorded, helping them step by step understand the object's extraordinary behavior. To not miss the next discoveries, click subscribe and like the video to follow each measurement, each reflected light, and feel the mysterious rhythm that 3I Atlas brings, as if you are touching the sophisticated life of the universe. Observatories around the world quickly picked up on 3I Atlas. The object reflected light uniformly, with a magnitude ranging from 18.7 to 19.3, with a slender, elongated shape and an unknown mass. What was strange was its velocity, ranging from 60 km/s to 68 km/s, far exceeding any comet previously observed in the solar system. Scientists noted that the light emitted from its surface fluctuated slightly, giving the appearance that the object was adjusting its reflection to adapt to its surroundings. The measurements were compared between JWST, ground-based telescopes, and Mars orbiter radar to confirm consistency. All the data were consistent, suggesting that 3I Atlas behaved in a sophisticated, unnatural way. Humanity is facing a big question. Is this object just an unknown natural phenomenon, or is it the mark of a sophisticated and purposeful extraterrestrial intelligence? If you are watching from your screen, leave a comment. Do you think 3I Atlas is natural or artificial? Let's explore and share our hypotheses together. Every detail, every light fluctuation that this object brings. Unlike any previous interstellar object, 3I Atlas decelerates as it approaches the Sun. Its initial velocity is about 68 km/s, dropping to 67.5 km/s at perihelion. The orbit is stable, but no gas trails or jets are visible. Measurements from JWST, radar, and Mars orbital Doppler confirm this phenomenon lasts for days and raises major questions about its origin and mechanism. This opens up two possibilities. One is that 3I Atlas is an unknown natural phenomenon. The other is that the object is a sophisticated instrument, bearing traces of extraterrestrial intelligence. Scientists record every single detail: light fluctuations, velocity changes. Each measurement contributes to building a theoretical model to explain the irrational behavior. Humanity realizes that every observation is an opportunity to reflect on the universe, and that sometimes phenomena beyond theory open up door of discovery. Scientists are beginning to consider several hypotheses to explain 3I Atlas's strange deceleration. One possibility is a solar sail. The object could reflect photons in a way that creates drag, but to adjust its orbit and maintain long-term stability. This mechanism would need to be more sophisticated than any known natural phenomenon. A second possibility is an as-yet unknown technology. A tiny electromagnetic or ion thrust could explain the deceleration and also allow the object to adjust its orbit without creating a trail. A third possibility is the use of planetary gravity. 3I Atlas could use the influence of Mars or Jupiter to adjust its orbit in subtle ways, as if the object were looking back at Earth. Each hypothesis is unusual and challenges current science, but it is these possibilities that expand the way in which interstellar objects might interact with their environment, and suggest that 3I Atlas is no longer simply a comet. Oumuamua first appeared, 2017. Slender, cigar-shaped, spinning chaotically, accelerating away from the sun without leaving a tail or escaping gas. Scientists debate whether this is a natural object or an extraterrestrial technology. Borisov appeared in 2019, has a tail, exceeds standard speed. Orbit is similar to a comet, but still has abnormalities that need careful analysis. Observations help realize the increasing complexity compared to Oumuamua. 3I Atlas, 2025, appeared later. Hollow structure, special light reflection, unusual deceleration, emitting radio signals, irrational behavior beyond all theories, creating the most sophisticated test for humanity. Comparison of three objects shows a chain of evolution in interstellar phenomena. Each appearance is a step to challenge the ability to observe, analyze, and understand. Humanity begins to recognize raw. Interstellar objects are not just random natural phenomena, but may be a series of sophisticated lessons or experiments. Spectroscopic observations from JWST revealed that 3I Atlas has an unusual chemical composition. In particular, CO2 is 10 times higher than normal, along with high nickel but almost no iron, a ratio that is completely opposite to known comets. In addition, complex carbon compounds were detected, similar to biological or artificial systems. These signs suggest that the object may not be a natural object, but rather a sophisticated engineered or reinforced object, capable of surviving and adapting its behavior in harsh environments. Scientists analyzed every detail of reflected light, each plasma oscillation and hollow structure, to build models of materials and load-bearing capacity. These results not only challenge current theory, but also open up the possibility of extraterrestrial technology. Philosophical implications also emerge. 3I Atlas reminds that, in the universe, not all objects obey the rules we know, and every discovery is a step of learning, observation, analysis, and creative thinking. 3I I-Atlas orbit measurements surprise and fascinate scientists. The object's velocity varies from 60 km/s to 68 km/s, decreasing as it approaches the Sun, a behavior never seen before in any comet. Observations from JWST, the Mars Orbit Radar, and Doppler observations from multiple ground-based telescopes confirm that the deceleration effect remains stable for days, cannot be explained by reaction forces or natural outgassing. Humans begin to record every smallest detail, every light oscillation, every orbit change. Every data is compared, meticulously analyzed, to build a theoretical model to explain the absurd phenomenon. The significance of these measurements goes beyond mere physics, helping humanity realize that the universe also contains sophisticated mechanisms that are not yet known, and every small data is an important clue for interstellar exploration. When 3I Atlas reaches perihelion, near the closest approach to Mars in late October 2025, it enters a special observation period where solar radiation peaks and all phenomena are intensified. Scientists have outlined several possible scenarios. Scenario 1. The object breaks up. If 3I Atlas cannot withstand the force, it will disintegrate, releasing gas, dust, and complex carbon compounds. This would resemble a traditional comet, but the previous deceleration and hollow structure are still not explained. Scenario 2. The object survives intact. If 3I Atlas survives perihelion, it demonstrates a hollow or sophisticatedly reinforced structure, capable of withstanding intense radiation, extremely low temperatures, and solar gravity. Scenario 3. Sophisticated orbital control. An extraordinary possibility is that the object will self-correct without the use of jets or the escaping gas, as if observing the Earth's position and adjusting its view. This raises questions about the sophistication and intent of the scientists. Follow-up observations from Mars, Jupiter, and JWST will confirm or disprove each scenario. Humanity is waiting in silence, watching every light fluctuation, every orbital change, every tiny signal, and every extraordinary behavior of the object. This perihelion moment is not only a challenge for science, but also a window into the understanding of this extraordinary interstellar object, a rare opportunity to witness the sophistication, complexity, and possibly the intentionality of the behavior of 3I Atlas. 3I Atlas is not just an extraordinary object, it is a challenge to modern science. Observations and data that are unconventional force astronomers to reconsider familiar assumptions about orbits, plasmas, and light reflections. If this object is a natural phenomenon, it opens up a new way of looking at interstellar matter, an opportunity for humans to learn to observe closely, integrate limited data, and build more sophisticated models. If it is artificial, a trace of extraterrestrial intelligence, humanity has just touched the first door of another civilization, a challenging experience in the ability to analyze, observe, and perceive. Each observation is a lesson, helping the scientific community recognize the limits of current understanding and at the same time learn patience, creativity, and sophisticated reasoning in the face of phenomena that go beyond theory. 3I Atlas also reminds that the universe is not always explainable by formulas. Each signal, light fluctuation, or orbit change is a valuable clue, opening opportunity to explore deeper into the interstellar universe and its sophisticated capabilities. 3I Atlas leaves the field of view but leaves questions hanging in the minds of humanity. The object not only challenges physics, orbits, or spectra, but also raises philosophical questions. Can this universe be fully understood, or will it always contain mysteries that cannot be explained? The answer is not clear, but the data, orbits, reflected light and radio signals are all important pieces of the puzzle for future interstellar exploration. Humanity has learned to observe meticulously, patiently, and analyze delicately. Every small detail is valuable. Every change is a hidden message. The universe, through 3i Atlas, seems to tell us that not every phenomenon has an immediate explanation. Not every orbit or light fluctuation follows the old theory. The universe refuses to be reduced to a solved equation. It remains vibrantly alive, endlessly mysterious, and yes, it is communicating with us. This message is not just a warning, but also an invitation. Observe, learn, reflect, and prepare for more sophisticated interstellar exploration, where science, curiosity, and imagination meet. When 3i Atlas was first discovered, the entire global astronomy community was surprised and intrigued. Telescopes from JWST, Mars Reconnaissance Orbiter, and ground-based observatories recorded every detail: orbit, velocity, reflected light, plasma oscillations. The data did not fit any previous physical models. The object decelerated erratically, leaving no gas or jet trail, in stark contrast to any known comets or asteroids. Scientists immediately compared the data to previous interstellar objects, like Oumuamua and Borisov, but 3i Atlas continued to behave in an independent, irrational manner, without any known patterns. Every observation was carefully recorded. Every light fluctuation, every change in velocity became an important piece. In the effort to understand the true nature of the object, this phenomenon forced humanity to change its scientific approach, focusing on meticulous observation, patience, and sophisticated analysis, preparing for the more complex interstellar discoveries that would come later. The unusual deceleration of 3i Atlas has forced physicists to reconsider the fundamentals of interstellar orbits. Previously, comets or asteroids could only accelerate when subjected to outgassing or solar radiation, but 3i Atlas decelerated with a velocity drop of about 0.5 kilometers s as it approached perihelion, without leaving any gas or jet trails. This phenomenon challenged the entire familiar physical model, forcing scientists to consider new hypotheses, from previously unidentified physical mechanisms to the possibility that the object was designed or controlled by extraterrestrial intelligence. The long-term consequences are: humanity is beginning to realize that the universe does not always obey known laws, and explaining the absurd phenomenon requires patience, careful observation, and creative thinking. Scientists also learned how to integrate multi-source data from JWST, radar, Doppler from ground stations, and compare it with previous interstellar objects such as Oumuamua and Borisov, to better understand its unusual and complex behavior. The 3i Atlas observations of deceleration raise the question: what force causes the object to move erratically, without creating a trail or jet? Scientists propose three possible mechanisms. Possibility 1 is a solar sail. Photons reflected from the surface create drag. However, to maintain a steady deceleration over several days, this mechanism would have to be more sophisticated than any known comet. Possibility 2 is an unidentified technology. A tiny ion or electromagnetic thrust could explain the deceleration and also allow the object to adjust its orbit, subtly without leaving a trail. Possibility 3 is using planetary gravity. 3I Atlas could use the influence of Mars or Jupiter to adjust its course, as if the object were looking back at Earth and changing its perspective. Each mechanism is unusual, implausible, and defies current science, but it also opens a new window on the possibility of interstellar objects interacting subtly with their environment, and suggests that 3I Atlas is more than just a comet. Oumuamua appeared in 2017. Slender, cigar-shaped object, spinning chaotically, accelerating away from the sun without leaving a tail or escaping gas. Observations raise questions about natural origin or extraterrestrial intelligence. Borisov appeared in 2019, carrying a tail of gas, speeding beyond the norm, orbiting in a not quite normal manner. Borisov's complexity and unusualness suggest interstellar objects have diverse behavior, not predictable by traditional comet models. 3I Atlas in 2025 surpasses both previous objects: void structure, different reflections, irrational deceleration, radio signals, sophisticated orbital adjustments, all create an unprecedented challenge for the scientific community. Comparison of 3 objects shows a chain of evolution in interstellar behavior. Each successive object brings greater complexity, prompting questions about the intentionality or control of these objects. Humanity has realized that observing interstellar objects is not only a science, but also a lesson in awareness, patience, and open-mindedness. Spectroscopic observations from JWST reveal 3I Atlas has an unusual chemical composition. Co2 is 10 times higher than normal, high in nickel but almost no iron, a ratio that is completely opposite to known comets. Complex carbon compounds are also present, similar to biological or artificial systems. These signs suggest the object is not entirely natural, may be a sophisticated, engineered, or reinforced object to survive and adapt its behavior in the harsh environment of the solar system. Scientists analyze every detail of reflected light, every plasma oscillation and hollow structure, build models of materials, densities, and resistance. Results challenge all current theories and open up the possibility of extraterrestrial technology. Philosophical implications. 3I Atlas is a reminder that not all objects follow known rules. Every discovery is a lesson in observation, analysis, and creative thinking. 3I Atlas's orbital measurements are not just numbers, but a living record of an absurd phenomenon. The object initially moves at a velocity of about 68 kilometers s, but as it approaches the sun, it suddenly slows down, a behavior never seen before in any comet or asteroid. The JWST telescopes record minute fluctuations in light. The Mars Orbiter radar tracks the orbital changes meticulously, and Doppler measurements from ground-based telescopes confirm that the deceleration lasts for days, unexplained by conventional reaction forces or outgassing. What's remarkable is that 3I Atlas's trajectory remains perfectly steady, as if the object knows how to maintain its orbit and adjust itself to the pull of the sun and surrounding planets. Humanity recorded every single detail, from light fluctuations to changes in velocity. Each data was meticulously analyzed, building theoretical models to explain this irrational behavior. The deeper meaning is, each observation is a lesson in the limits of understanding, a reminder that in the universe, not all phenomena follow known theories, and it is precisely the irrationalities that open the door to new discoveries, a rare opportunity to understand how interstellar objects interact delicately with their surroundings and with the solar system. As 3I Atlas approaches perihelion, near Mars's closest approach in late October 2025, the object enters a special observation period, where solar radiation is at its peak and all phenomena are amplified. Scientists have outlined several possible scenarios. Scenario 1. Structural breakdown. If 3I Atlas cannot withstand the force, it will disintegrate, releasing complex carbonaceous gases and dust. This would resemble a traditional comet, but would still not explain the previous deceleration and hollow structure. Scenario 2. Survival intact. If 3I Atlas survive perihelion, it would demonstrate a hollow or sophisticated reinforced structure capable of withstanding intense radiation, extremely low temperatures, and solar gravity. Scenario 3. Sophisticated orbital adjustment. An extraordinary possibility is that the object adjusts its orbit itself without using jets or escape gases, as if observing Earth's position and adjusting its view. Further observations from Mars, Jupiter, and JWST will confirm or rule out each scenario. Humanity is waiting in silence, watching every light fluctuation, every orbital change, every tiny signals, and each extraordinary behavior of the object. This perihelion moment is not only a challenge for science, but also a window into the understanding of this extraordinary interstellar object, a rare opportunity to witness the subtlety, complexity, and possibly intentionality of 3I Atlas's behavior. 3I Atlas is more than just a strange object. It is a reminder that the universe is always unpredictable. Scientists observe every oscillation of light, every change in velocity, but have yet to fully explain the object's irrational behavior. This suggests that sophisticated interstellar phenomena may exist, far beyond what current physics predicts. If 3I Atlas is natural, it opens up new perspectives on the mechanics of interstellar matter, helping astronomers build more sophisticated observational models and prepare for more complex objects in the future. If the object is artificial, a trace of extraterrestrial intelligence, then humanity has just reached a first observational step of sophistication, intentionality, and mechanisms beyond current understanding. These data remind us that science is not just about explaining phenomena, but also about recognizing, analyzing, and learning from the unexpected. Every orbit, every reflected light, every tiny oscillation is a valuable clue, opening a new door to a deeper understanding of the interstellar universe. As 3I Atlas leaves the field of view, humanity no longer feels that the universe is something that can be fully explained. The object not only challenges the laws of physics, but also raises philosophical questions. Can the universe be fully understood, or will it always contain mysteries that cannot be explained? The orbital, reflected light, and deceleration data are valuable clues for future interstellar research. Humanity learns to observe, be patient, and analyze carefully, realizing that every small detail counts. Every light fluctuation is a hidden message. The universe, through 3I Atlas, seems to tell us that not every phenomenon has an immediate explanation. Not every orbit or light fluctuation follows the old theory. The universe refuses to be reduced to a solved equation. It remains vibrantly alive, endlessly mysterious, and yes, it is communicating with us. This message is not just a warning, but also an invitation. Observe, learn, reflect, and prepare for more sophisticated interstellar exploration where science, curiosity, and imagination meet. As 3I Atlas approached the Sun, astronomers noticed something unusual. The object was slowing down unexpectedly, unlike any comet or asteroid ever observed. 3I Atlas initially moved at about 68 kilometers s, but as it neared perihelion, its speed dropped to 67.5 kilometers s. This change was subtle and steady, leaving no trace of gas or jets, leading scientists to suspect an unknown physical mechanism. Data from JWST, the Mars Orbiter Radar, and Doppler data from ground-based telescopes confirmed that the slowing down lasted for days, challenging all known orbital theories. This phenomenon reminds humanity that the universe is always full of extraordinary and sophisticated things, and each observation is a door opening to new knowledge, preparing for more complex interstellar objects in the future. Solar energy. Photons from the sun's light reflect off the surface, creating a slight but constant drag, affecting the velocity. For this mechanism to work, the surface of the object must be extremely reflective, thin enough to sense the photons, strong enough to survive the extreme pressure of solar radiation. Computational simulations show photon reflection forces can create a deceleration of about 0.5 kilometers s, but this still does not explain the entire irrational behavior, especially the ability to maintain a stable orbit for a long time. This idea forces humanity to combine light observations with physical models to assess whether photons can significantly affect the motion of delicate interstellar objects. A second possibility to explain 3I Atlas's deceleration is that the object uses a sophisticated internal mechanism, a tiny ion or electromagnetic force that can influence its orbit without leaving any gas or jets behind. Scientists simulated the range of ultralight ions to electromagnetic energy, finding that with its sophisticated hollow structure, the object can self-balance and adjust its direction of travel, keeping a stable orbit while decelerating at an extraordinary rate. If this mechanism is correct, 3I Atlas would be the most sophisticated object ever observed, far surpassing all known comets and asteroids. It also raises questions about the object's origin and complexity, and opens up the possibility of extraterrestrial intelligence or other unnatural mechanisms that have not yet been documented. A third possibility is that 3I Atlas uses the gravity of planets to adjust its orbit. When passing near Mars or Jupiter, the object can glide through gravitational fields, changing course without jets or escape gas. Orbital simulations show that 3I Atlas can identify key locations in the solar system and fine-tune its path, as if the object were observing Earth and adjusting its position to make it easier to track. This ability partly explains the deceleration and maintenance of a stable orbit, but it does not fully explain the reflected light behavior and hollow structure. This suggests that the object has the ability to be complex, sophisticated, challenging all traditional physical hypotheses. Looking at three possible mechanisms for 3I Atlas's strange deceleration, scientists began comparing each detail, each data point, to find which possibility best fit the observations. Mechanism 1. Solar sail. Photons from sunlight reflected off the object's surface, creating a slight but constant drag. Models suggest that deceleration of about 0.5 km/s is possible. But this mechanism does not explain 3I Atlas's long-term stable orbit and its unique reflected light behavior. Mechanism 2. Unknown technology. A tiny ion or electromagnetic thrust could create deceleration and orbit correction without creating a trail. Simulations suggest that an object with a sophisticated hollow structure could self-balance and maintain a stable orbit. This ability explains much of the irrational behavior, from deceleration to course correction. Mechanism 3. Using planetary gravity. 3I Atlas uses the pull of Mars, Jupiter, to course correction, as if observing the position of Earth and fine-tuning the view. This mechanism helps maintain a stable orbit but does not explain end of the phenomenon of reflected light and hollow structure. When comparing the three mechanisms, humanity realizes that each possibility is unusual and absurd, but when combined, a picture gradually forms. The object may be a mixture of unknown physical phenomena and sophisticated abilities, a system that operates autonomously, delicately, beyond all old theories. As 3I Atlas moves out of direct observation, humanity is left with a series of unanswered questions. 3 possible mechanisms: solar sails, unidentified technology, and leveraging planetary gravity. Each opens up different avenues of inference about the object's strange behavior, deceleration, and subtle capabilities. These data are not just physical figures, but also stories of intelligence, observation, and creativity. Humanity has learned to patiently observe, reading every detail of reflected light, every change in orbit, and every subtle signal that 3I Atlas leaves behind. The next chapter will open a new turning point. Further observations of the strange light behavior and signals, features that make this interstellar object unlike any comet or asteroid ever seen. Humanity embarks on a new journey where science, imagination, and curiosity meet, preparing for extraordinary discoveries to come. In 2017, a thin streak of light streaked across the sky, discovered by ground-based and space-based telescopes. The object, dubbed Oumuamua, had a long, narrow shape, unlike any known comet. The strange features immediately caught the attention of the scientific community. Tail, unstable rotation, and unusual acceleration as it left the solar system. Astronomers had to record every detail of the light, every tiny oscillation, to understand how the object interacted with solar radiation. Oumuamua was not just an object, but also a window into new understanding. It showed that interstellar objects could behave unconventionally, requiring humans to change the way they observed, analyzed, and thought. In this context, Oumuamua became a standard of comparison, a benchmark for interstellar objects that came after, helping humanity realize the diversity and surprise of planets and objects outside the solar system. In 2019, another object appeared in the sky, named Borisov. Unlike Oumuamua, Borisov has a distinct gas tail, like a traditional comet, but still has unusual characteristics. Borisov's velocity and orbit exceed the standard, compared to normal comets in the solar system, creating curiosity and debate in the scientific community. Astronomers recorded every change in light, every small fluctuation in orbit, searching for clues about the origin and material composition. Borisov helped humanity realize that interstellar objects are not random events. Each appearance brings with it a different level of complexity and characteristics. Compared to Oumuamua, it is a step forward in the chain of interstellar phenomena, opening up the possibility of comparing and analyzing the evolution of object behavior. Humanity is beginning to realize every interstellar object is not only a natural phenomenon, but also an opportunity to learn and expand awareness of the universe. In 2025, 3I Atlas appeared, an interstellar object with behavior far beyond that of Oumuamua and Borisov. It had a hollow structure, reflected light exceptionally, and slowed down erratically as it approached the sunday. Unlike traditional comets, 3I Atlas emitted strange radio signals, made subtle orbital adjustments without leaving behind gas trails or jets. Measurements from JWST, Mars Orbiter Radar, and ground-based telescopes recorded every light fluctuation, every velocity change. Every detail was meticulously analyzed to understand the nature of the object. Compared to the previous two objects, 3I Atlas gradually increased in complexity, from the unusual acceleration of Oumuamua to the unusual orbit and gas tail of Borisov to the strange behavior, signal, and hollow structure of 3I Atlas. This series of three objects is not only an astronomical phenomenon, but also a lesson in how to observe, analyze, and think about phenomena that go beyond theory. The three interstellar objects, Oumuamua, Borisov, and 3I Atlas, are not just fleeting streaks of light in the sky, but also subtle cosmic messages about how interstellar objects might move and interact. Oumuamua appeared in 2017. Slender, long, chaotic rotation, accelerated as it left the solar system, leaving no tail or gas trail. Scientists debate whether it was natural or a sign of extraterrestrial intelligence. Borisov appeared 2 years later, had a distinct gas tail, exceeded the standard speed. Orbit and reflected light were different from Oumuamua. Every light fluctuation, every orbit change was recorded in detail, showing that interstellar objects can behave with increasing complexity. 3I Atlas appeared in 2025. Hollow structure, extraordinary reflected light, unusual deceleration, radio signals, sophisticated orbit adjustments. It surpassed all previous interstellar objects, becoming a sophisticated experiment of the universe. When observing the three objects as a whole, humanity realized a series of evolutions in interstellar physical behavior. Each the objects that appear are more complex than before, opening new questions about how the universe operates. These data are not just physical figures, but also lessons in observation, analysis, and expanding awareness, reminding that the universe always contains phenomena beyond theory, and each appearance of an interstellar object is an opportunity for humanity to expand its vision and imagination. When comparing the three interstellar objects, it's not just the orbits and movement behavior that have scientists' attention, but also the chemical composition and material structure that reveal profound differences. Oumuamua is relatively dense. The material is mostly rock and ice. There is no evidence of high metal content or complex compounds. This makes it an extraordinary natural phenomenon, still within the limits of current physical understanding. Borisov is different. It has a distinct tail, mainly from CO and CO2, accompanied by carbon compounds, showing that the chemical system has many similarities with comets in the solar system but the speed and orbit are still unusual compared to predictions. 3I Atlas far exceeds both. Co2 is 10 times higher than normal. Nickel is abundant but almost no iron. Complex carbon compounds appear. The reflected light and hollow structure suggests the object is not entirely natural. Maybe it is a sophisticated manufactured or reinforced object. Comparison of the three objects shows a series of chemical and structural evolution, from the natural composition of Oumuamua through the chemical system with the Borisov tail, to the unnatural composition and complex structure of 3I Atlas. By analyzing orbital measurements and physical behavior, humans realize that each interstellar object has its own characteristics, from the influence of planetary gravity to its response to solar radiation. Oumuamua moves fast, spins chaotically, accelerates abnormally as it leaves the solar system, but does not create a trail of gas or dust, keeps a stable orbit during short observation periods. Borisov has a distinct gas tail, mostly CO and CO2. Orbit and speed exceed standards, but behavior is still relatively consistent with comet models, giving humanity an opportunity to understand how matter flies through the solar system. 3I Atlas is more complex. Poor structure, unusual reflections, irrational deceleration when approaching the sun, sophisticated orbit adjustment without jets or escape gas. Scientists must combine data from JWST, Mars radar, and ground-based telescopes to build a model that explains the object's physical behavior, orbit, and subtle interactions. Comparing the three objects shows interstellar objects differ not only in shape or speed, but also in how they respond to gravity conduction, radiation, and surroundings. Looking at the three interstellar objects as a whole, Oumuamua, Borisov, and 3I Atlas, humanity is beginning to recognize a subtle progression in behavior and orbit. Oumuamua appeared in 2017. Fast, chaotic rotation, unusual acceleration, leaves no gas or dust trail, relatively straight orbit. Humanity learns to observe absurd phenomena in limited time. Borisov appeared in 2019. Gas tail, overspeed, curved orbit, more complex behavior than Oumuamua, light fluctuations, velocity and orbit changes carefully recorded, creates a basis for seeing evolution in interstellar behavior. 3I Atlas appeared in 2025. Void structure, extraordinary reflections, unusual deceleration, radio signals, sophisticated orbital adjustments without leaving a gas trail, behavior far beyond the previous two objects, suggests sophisticated extraterrestrial intelligence or mechanisms. This series of three objects shows each appearance is a step forward in complexity, complex, opening up opportunities for humanity to improve its ability to observe, analyze, and imagine subtle interstellar phenomena never before seen. Comparing Oumuamua, Borisov, and 3I Atlas reveals a sequence of interstellar evolution. Each object appears to have increasing complexity, from unusual accelerations to unusual gas tails to the bizarre behavior, hollow structures, and subtle signals of 3I Atlas. These observations are not only physical data, but also lessons in observation, analysis, and creative thinking. Humanity has learned to record each light oscillation, each change in velocity, and each extraordinary behavior of interstellar objects. This series of three phenomena reminds us that the universe always contains surprises, sophistication, and beyond theory. Each appearance of an interstellar object is an opportunity for humans to expand their vision, imagination, and cognitive abilities. Through this, humanity not only understands orbits or matter, but also learns patience, sophisticated analytical ability, and open-mindedness, preparing for the next extraordinary discoveries in the interstellar universe. Recent observations from JWST and ground-based telescopes reveal a unique chemical composition of 3I Atlas, never seen in any interstellar object before. CO2 is abundant, about 10 times more than a typical comet. Nickel, meanwhile, is abundant, and iron is almost completely absent. This contradicts all physical models of metal distribution in natural celestial bodies. In addition, complex carbon compounds are also present, with structures that resemble biological systems or sophisticated technology. These findings suggest that 3I Atlas may not be just a natural object, but a specially engineered or reinforced entity to withstand the extreme low temperatures, intense radiation, and harsh gravity of the solar system. Scientists record every detail, every light fluctuation, every orbital change, with the goal of deciphering the physical nature and extraordinary mechanism of the object. The deeper meaning is, each measurement is not just chemical information, but also a clue to sophisticated capabilities, intention, or unknown mechanisms in the universe, opening the door to interstellar discoveries beyond current theory. Orbital observations and data from JWST show that 3I Atlas has a hollow structure inside. This explains why the object can decelerate abnormally and still maintain a stable orbit. Its mass is much lower than that of a solid object of the same size. This means that 3I Atlas can withstand the extreme force of solar radiation and the gravitational forces of planets without breaking apart. Simulations indicate that the object can survive intact through impacts that ordinary comets cannot. This hollow structure, combined with its extraordinary spectral characteristics, suggests that the object can self-balance and regulate its behavior. These findings suggest that 3I Atlas is no longer an ordinary comet. It could be a sophisticated, specially designed or reinforced entity, opening up a whole new layer of interstellar exploration. As 3I Atlas approached the Sun, the light reflected from the object's surface increased dramatically beyond expectations. This phenomenon was unlike any other observed comet, and the light fluctuations were constantly and subtly changing. Scientists noted some areas were brighter than normal. The plasma outside the object's surface vibrated in rhythm with the radiation, creating a vivid light effect that current physical models have difficulty explaining. The object appeared to not only reflect light, but also respond to its surroundings, fine-tuning its orbit and evolving its light according to each position in its orbit. This phenomenon revealed an unconventional way of existing, a sophisticated nature never seen before in any interstellar object, raising questions about the physical mechanism or internal control of 3I Atlas. Amidst the myriad stars, 3I Atlas emitted a strange radio signal, a subtle message that stations on Earth simultaneously received. The signal did not resemble noise, did not originate from the sun, and did not match any previously recorded astronomical phenomenon. Scientists began analyzing the frequency, period, and intensity of the signal, tiny details that revealed the object's internal structure and its ability to interact with its environment in a sophisticated way. This phenomenon suggested three entirely new hypotheses. The object was sending the signal as a form of warning, The signal was an internal communication mechanism, or it was an unknown physical reaction when the object experienced extreme pressure, radiation, and temperature. What is special is that this signal is not simply a radio wave, but reflects extraordinary behavior. The object adjusts its intensity and frequency according to its position in orbit, as if responding to its environment and observing the Earth. Humanity is beginning to realize each signal oscillation is a layer of information, a clue to sophisticated capabilities, and possibly a sign of unknown intelligence or mechanisms. 3I Atlas observations show reflected light, plasma, and ion particles interacting in a complex way with the surrounding environment, not just an optical or radio phenomenon. Each light oscillation reflects the reaction of the matter inside to solar radiation and planetary gravity. Analysis shows the plasma around the object moves in non-uniform directions, apparently fine-tuning the orbit and speed of 3I Atlas. The radio signal varies slightly with the intensity of the radiation, suggesting that the object can respond to light and the interstellar medium. The reflected light oscillates periodically, reveals the structure of matter and the ability to absorb and emit sophisticated energy. This ability opens up three entirely new hypotheses. 3I Atlas is a sophisticated self-regulating object with unknown physical mechanisms. The light signals and oscillations are active feedback, programmed inside the object. This phenomenon is a complex interaction between plasma, light, and force attractive that current physical theory has not yet fully explained. Through these analyses, humanity realizes that 3I Atlas not only moves, but also interacts and responds to the environment in a sophisticated way, opening a new layer of discovery about the mechanism of interstellar matter and the extraordinary possibility of existence. Observations of 3I Atlas show that the object is not just drifting through space, but also displaying sophisticated adaptations to the surrounding interstellar medium. Changes in speed, light, and radio signals appear in sync with its position in orbit, as if the object senses and responds to its surroundings. The hollow structure and unusual chemical composition help 3I Atlas withstand solar radiation and the gravitational pull of nearby planets. This allows it to maintain a stable orbit, even through conditions that would otherwise cause a comet to break up. Simulations show that the object can fine-tune its plasma and reflected light to balance the forces acting on it, keeping its orbit and speed steady. Each oscillation in light, each small change in orbit, is a sign of sophisticated interaction and adaptation, possibly due to unknown physical mechanisms or internal programming. This phenomenon suggests a new perspective. 3I Atlas is not simply a star broom, which is an interstellar entity with extraordinary adaptability and survival capabilities, opening new doors to explore the subtle physical and behavioral mechanisms of the universe. Through observations of chemistry, hollow structure, light, and signal, 3I Atlas appears to be more than just an ordinary interstellar object. Every feature, every light fluctuation, every orbital change reveals a level of sophistication and non-traditional. Humanity realizes that the interstellar universe is not just a physical playground, but also a lesson in adaptability, response, and sophisticated survival. The collected data will lead to further analysis of the three most important interstellar objects, Oumuamua, Borisov, and 3I Atlas. In 2017, an interstellar object appeared in the night sky. Named Oumuamua, It was unlike any comet or meteorite ever recorded. The object was slender, long and narrow. Looked through a telescope, the reflected light fluctuated continuously. The initial orbit moved at about 26 kilometers s, but subsequent measurements showed unusual fluctuations. Astronomers recorded each light oscillation, each small change in orbit, to determine whether Oumuamua was a natural physical phenomenon or a sign of a sophisticated mechanism never seen before. As it accelerated as it left the solar system, the object sparked many hypotheses, from solar radiation reactions to the possibility of a complex internal structure. Oumuamua's observation became a milestone, a benchmark against which later interstellar objects were compared. Humanity realized that each oscillation dynamic, every small change is a valuable clue to understanding how interstellar objects interact with the solar system. In 2019, Borisov appeared an interstellar object different from Oumuamua. The object has a distinct gas tail, reflecting high CO and CO2 content. Borisov's orbit is curved, and its speed exceeds the standard, unlike a typical comet in the solar system. Ground and space telescopes recorded every light fluctuation, every small change in velocity. Each data was meticulously analyzed to understand the object's interaction with gravity and radiation. Borisov proved that the interstellar object does not simply move in a straight orbit, but reacts subtly to its surroundings, opening a new step in the study of interstellar physical behavior. Borisov observations prepare for comparison with 3I Atlas, the object that appeared in 2025, helping humanity realize the increasing complexity in the behavior and orbit of the three interstellar visitors. In 2025, 3I Atlas appeared, an interstellar object more complex than both Oumuamua and Borisov. Ground-based telescopes and JWST recorded orbits, with subtle changes that could not be explained by conventional jets or outgassing. The initial velocity was about 68 kilometers s. After approaching the Sun, it dropped to 67.5 kilometers s, a behavior never seen before in comets. The reflected light and plasma around the object oscillate periodically. The radio signals are subtle. All three factors are synchronized with the orbit. Detailed measurements show that 3I Atlas can self-balance, adapt, and respond to its environment, maintaining a stable orbit while experiencing intense radiation and gravity from nearby planets. 3I Atlas observations provide a complete picture of how sophisticated interstellar objects can interact with the solar system and raise profound questions about their origins, mechanisms of existence, and their capabilities. When Oumuamua, Borisov, and 3I Atlas are placed side by side, a sophisticated evolution of interstellar behavior emerges. Oumuamua moves fast, rotates chaotically, accelerates abnormally as it leaves the solar system. No gas tail or dust trail, nearly straight orbit. Light fluctuations reveal subtle physical reactions. Borisov appears 2 years later, has a distinct gas tail, speeds beyond standard, orbit curves, light fluctuates in a more complex pattern. Object interacts strongly with environment. Level of sophistication surpasses Oumuamua. 3I Atlas in 2025 decelerates from 68 kilometers s to 67.5 kilometers s. Hollow structure, extraordinary light reflection, emits radio signals, adjusts orbit without jets. Every light fluctuation, Every small change in orbit is a sign of the mechanism's sophisticated or hidden intelligence. The series of 3 objects shows increasing complexity from Oumuamua, Borisov, 3I Atlas, deceleration and orbits that cannot be fully explained by classical physics. This series of data becomes a reference for analyzing all interstellar objects that appear later. Humanity realizes that the interstellar universe always contains sophisticated, unexpected, and beyond the theoretical phenomena. Each appearance is an opportunity to expand the vision and imagination. Measurements show 3I Atlas decelerates in an unusual way compared to a typical comet. Initial velocity of about 68 kilometers s drops to 67.5 kilometers s as it approaches the Sun. This phenomenon lasts for days, leaving no gas trail or sign of jets. 3 possible scenarios considered by scientists. The first possibility is the force of sunlight. Photons continuously impact the surface of the object, creating a slight but steady drag, helping the object decelerate without jets or escape gas. The second possibility is an unknown internal mechanism. The object may use microscopic, ionic, or electromagnetic forces to fine-tune its orbit and decelerate in a sophisticated way. Simulations show that a hollow structure, combined with internal forces, could explain most of the observed strange behavior. The third possibility is to take advantage of planetary gravity. 3I Atlas glides through the gravitational fields of Mars and Jupiter, fine-tuning its orbit without no need for jet or exhaust gas. This mechanism may explain deceleration, but does not fully explain the variations in light and radio signals. Measurements of the orbits and decelerations of Oumuamua, Borisov, and 3I Atlas are more than just numbers or physical diagrams. They reveal how interstellar objects interact in a sophisticated way with their environment. Oumuamua teaches humanity about unusual orbital fluctuations. Borisov reveals more complex behavior of matter and escaping gas. 3I Atlas reveals self-correcting orbits, irrational decelerations, and signaling. These data motivate scientists to not only explain the phenomenon, but also test new hypotheses, put limits on modern physics and the viability of interstellar objects. These measurements also lay the foundation for future object predictions and observations, and open questions about the viability, adaptability, and sophistication of interstellar objects. Humanity realizes that the universe is not just a series of linear orbits, but a web of interactions, complex, sophisticated, and always full of surprises. Every observation is an opportunity to expand your imagination and understanding of the interstellar world. Measurements of the orbits and decelerations of Oumuamua, Borisov, and 3I Atlas not only provide physical data, but also open a whole new window into how interstellar objects interact with the cosmic environment. Oumuamua teaches humanity about unusual fluctuations and irrational behavior. Borisov reveals more complex behavior of matter and escaping gas, with curved orbits and subtle variations in light. 3I Atlas surpass both irrational decelerations, radio signals, and subtle orbital adjustments, each of which opens up unprecedented questions. This trio of objects emphasizes that the interstellar universe is not just a place where physics rules, but also a complex playground where subtle, unexpected, and unexplained phenomena exist. Each light fluctuation, each orbital change, is a valuable clue, encouraging humanity to observe more carefully, to analyze meticulously more, and keep your imagination open. These findings not only impact astronomy, but also suggest concepts about the existence, adaptation, and sophisticated mechanisms of interstellar objects. Each measurement is a window into a deeper understanding of how the interstellar universe works and of how humanity can prepare for unprecedented discoveries. As 3I Atlas approached perihelion, within a distance of just 0.